Hi everyone, welcome. Welcome to Solar Simplified. This is Conrad Chase with PV Booster. Excited to have you guys on the line today. We're talking about rooftop tracking. We're talking about the commercial and industrial solar rooftop business, and most importantly, how rooftop tracking affects the financial impact on projects in the changing TOU rates here in California. We are joined by Evan Sarkeesian from Helia Scope and Adam Gurza, COO of Energy Toolbase. And we have a guest appearance by one Mr. Rusty Wood, Vice President of West Hills Construction, who has hands-on experience with trackers and long-time solar veteran here in the SoCal market. We're going to wait just a few minutes to allow a few others to hop on. And while we're waiting, just a couple housekeeping items. We have about 25 minutes of content from myself, Evan, and Adam. After that, we're going to open it up for plenty of time for Q&A. Throughout the first 20 or so minutes, please submit any questions through the Q&A chat feature on Zoom, and we will tackle as many as we can in the time that we have left after the presentation. Let's give it just a couple more minutes here. Yeah, the webinar and this topic was inspired literally by hundreds of conversations we've had with EPCs over the last year that are, one, looking for new and effective ways to break into the CNI market, and two, have consistently been concerned with how these TOU rates and the changing rates are going to affect their solar business. And today, as you'll hear from Adam Gurza from Energy Toolbase, the TOU rate timing has already gone into effect in certain utilities, and the others are very quickly right behind. Let's give a couple more seconds here and we'll get started. All right, great. Let's get into it. Our agenda today is first and foremost why we are so excited about the CNI Marketplace. This is a topic that we had the pleasure of speaking on at Intersolar this year. We are going to be laying out in Helia Scope a step-by-step walkthrough of a tracker system on a rooftop in San Diego gas and electric territory. We're going to model a tracker output using off-the-shelf NREL tools. Then we're going to have a financial analysis comparison of trackers on a roof compared to a fixed tilt 10-degree system. And like I said, we'll leave it open for Q&A at that time. So why are we so excited about the CNI Marketplace? There is a lot of electricity consumed by buildings, period. And that consumption is only continuing to rise. Along with the rise in electricity consumption and cost is increasing budgets that commercial and industrial corporate customers are allocating to solve, quote, the energy thing. This chart is showing the increasing future demand of electricity use, as well as the increased interest in using renewable energy to offset that demand. So as we got more in depth into the details of this nuances to the CNI Marketplace, what we found is that there is a lot of money already being spent on these types of solutions. In 2016, there was approximately $72 billion spent in the US on solving the energy thing. Of that, only $4 billion was spent on solar. And of the $4 billion, only a fraction was spent on rooftop solar. The rest was all spent with competing solutions, HVAC systems, new roofing, LED lighting is a big up-and-coming theme. So the idea of approaching commercial and industrial customers with a solar-only solution, compounded by the fact that it's now less impactful with the changing TOU rates, has literally left the CNI solar rooftop market in the dark. At the same time, there are 50 billion square feet of available open roof space in the US, making rooftop solar literally a $1 trillion plus opportunity in the US for solar developers and installers. And this is what excites us, is that as we'll see in the analysis and the walkthrough, trackers specifically are opening this market up for EPCs from the additional value that's added from tracking that either can be saved by clients and saved by corporate customers, or that extra savings can be used by the client to complete some of these additional energy saving measures that are already at top of mind and put into their budget. So this is not all pie in the sky. This is a project, a 1.2 megawatt project completed in 2017 in Oxnard, California, using trackers. The project was a great case study for what's going on in the CNI space, in that the extra value from the tracking allowed the building owner, who was the ultimate customer, to afford a new roof, which needed to be done anyways. The EPC, who I'll introduce in a second, was able to not only do the solar project, which was contingent on some of these other budgetary constraints, but they were able to include the roof replacement as part of their EPC scope of work, which increased their revenue. And then the building owner obviously has a beautiful high-performing solar project on the roof, which some of those savings they're sharing with the tenant, increasing the value of their building, etc. This project specifically was developed and installed by West Hills Construction. And as I mentioned earlier, we have their VP, Rusty Wood, with us, who is available to answer questions about the install, this project, some of the nuanced specific technical design of the project during the Q&A section. So for today, we are going to Vista, California. We have a client that is in the logistics and manufacturing business. The building is approximately 106,000 square feet, owner-occupied building. We have a San Diego Gas and Electric territory for utility. And for this project, we are assuming using a PV Booster single-axis rooftop tracker as the technology for the site. So let's turn this into a real project. The next steps, first, to lay out the tracking system for the first time ever in history on a rooftop using Helia Scope will be Evan Sarkeesian. Evan is the Senior Customer Success Manager at Helia Scope. Once he is done with his layout, which will assess the size and envelope of the DC size of the building, or excuse me, of the solar project on the building, Evan will pass the controls to Adam Gerza from Energy Toolbase, who will complete the output model and energy bill analysis. So with that, I would like to pass the controls to Evan.
Awesome. Thanks so much. Let me just share my screen here. All right, and let me close this. Okay, so for those of you who are not familiar with HelioScope, I did check out the participant list and I did see some familiar names. So hello, everybody who knows me. For those of you who do not, HelioScope is basically a fast and easy way of laying out and modeling the production of solar arrays built from the ground up to support solar. It automates a lot of the workflow and layout tools, and also exports to CAD if you need to do that. So it's a really great way of prospecting and getting a quick answer to a customer about what the layout is going to look like and how much it's going to produce and that sort of thing. So to get started, I've just logged into helioscope.com, And I'm going to create a new project. One thing that I've done before this call is I've created a profile based on that design guide that we were showing in the previous slide. I basically set up a profile with all the default assumptions for this project. So you'll see that really quickly here. So let me just give this a name. We'll call this our tracker project and an address. So I type in this address, it takes me to the location. And then under profile, I'm going to select the profile that I pre-created here, which is PVV profile. And that's going to preload the tracker assumptions. So I'm going to create this new project. That's going to take me into my project page. And for just this demo, I'm just going to focus on creating designs. So I'm going to create a new design. And we can give this a name if we want to. So if we're going to step through different iterations, we might call this one tracker and then create another one that's the fixed tilt if we want to compare them, for example. But once you create the design, that'll take you into a Google Map interface. We can switch between different mapping providers if we want to, but for now I'm just going to use Google's image. And basically all I need to do here is define a field segment for the area where I want to define modules. So I'm going to click New to create a new module, or excuse me, new area. Click onto the sort of points of the roof that I want. And I'm holding Shift to give me 90-degree angles locked in. And then I just continue my shape all the way down here. And this gets over here. So I'm basically just continuing to click around the roof. This is pretty basic stuff. Anybody can do this. You don't need to be a sophisticated CAD user to use HelioScope. And so you can see once I finish my shape by double clicking, the modules lay out with the assumptions of this profile. So it has the module preloaded. This is fixed tilt racking. So this is, I'm just taking all of this from their design guide. So it has the tilt of 30 degrees, which is really just for representation in the model. And then row spacing of 4.36, and then module spacing of 1.14. So that's basically just preloaded for me. I can change these if I wanted to. But for now, the quick thing is to just right click on the midpoint of a line, set my azimuth. And this is just to get the layout. Obviously, the azimuth of these modules is going to change as this is a tracking array. So, you know, if you have a poor building orientation, you're not going to have to suffer through that with this tracker. So that's one advantage there. And I'm just going to right click here to align my modules to the left a little bit. And so you can see how quick and easy it is to lay out modules. This is also a 3D structure if we want it to be. So if I give this building a height, we can see this in 3D. So we can see how this is laying out, what these look like side by side. Now, what you would need to do, of course, is avoid obstructions. And since we have a lot to cover here, I'm just going to really quickly just say this area is off limits and just draw in keep outs for this area. You can define a setback from that object, but for now, I'm just going to create copies of it by holding the Alt key, clicking and creating copies. So I get as many copies as I need of similar shaped objects. Let's grab one over here, one over here. And then it looks like we have a little bit of a smaller group here. So I'm just defining the obstructions on this array pretty quickly. And one of the nice things with HelioScope is that you can do different versions. You can say, just to give this customer an answer, I'm going to do this quick version just to get an assessment of what is possible. And then if you get closer with that customer to closing, or maybe they sign a contract and you want to go a little bit deeper, you can draw each of these individually. You can model the 3D shapes if you really want to. But for our purposes, I think it's fine to just make this. Looks kind of like a SIM card. Okay, so that's my layout. This is how the modules are fitting in here. I might make some minor adjustments. I might move this one up, for example. Might move this over. But otherwise, I think this looks pretty decent. And we can go from there. If there's individual modules that we want to remove, we can just right-click to remove them. So if you're in keep out mode, you can just right-click on modules to toggle them on and off. So maybe I'll do that for this one here. Okay, so that looks pretty good. So now once I'm satisfied with the layout of the array, I can move on to electrical. And again, I predefined the inverter and optimizer So this is automatically laying out with a solar edge 33.3 based on a 1.35 DC to AC ratio. So I just define that in my profile. Of course, I can change the inverter count. We have the wire gauge, so we can see the voltage drop by wire gauge. So if we want to quickly optimize the conductor size, we can do that. We can view the single line diagram of how this is connected electrically and export this to CAD. And if we save and exit, we'll get a design summary. So we can see that this tracker layout, how many inverters are used, how many strings, and what's their total length, number of optimizers and number of modules, and then a picture of the array that we can show the building owner to give them an understanding of where the tracker is going to be laid out. And then if I want to take this layout into CAD, I can do that. I can click export and download a DXF of this layout and open it up in CAD. Of course, we also have the ability to integrate with Energy Toolbase and bring data into Energy Toolbase. And I'm basically done with my design at this point. So I'm finished with laying out the array. You can see that was pretty quick. And so now I'll hand this over to Adam from Energy Toolbase to show us sort of the tracker modeling and financial modeling pieces.
Awesome. Thank you, Evan. Let me steal the screen share and show my screen now. And also thank you to Conrad and the PV Booster team for having me on today. I am always excited to talk about time of use rates and avoided cost analysis for those of you that know us, which is really what my section of the presentation is going to focus on. So I'm assuming a lot of the folks on the line already know Energy Toolbase. For those of you that don't, let me just spend 30 seconds. We are a software as a service tool, and we specialize in modeling and proposing the economics of solar and storage projects. We're very objective and third party in our approach to figuring out savings. So I kind of want to make that disclaimer right up front on this webinar. We're certainly not in the business of endorsing or favoring certain vendors or technology, but rather we're taking a third-party approach and being very objective and transparent on solving for both avoided cost and the financial economics of the project. So without further ado, let's kind of jump into the meat of it, which is time of use rates. So as I'm sure almost everyone on the call is already aware, there are some very significant changes happening right now in California to rate designs, and specifically to time of use rates. So this slide here is for the case study rate we're going to be looking at today, which is the SDG&E DGR rate, which is the medium large commercial post solar rate. And we're comparing the July 1, 2018 rate versus last October's rate before they implemented this pretty radical change. And really the significant thing that a lot of folks have been talking about is how the on-peak period has shifted. Oh no, it looks like my thing just crashed. Hang on with me one sec, folks. I never have technical difficulties, but it looks like my slide deck just crashed. Let me try to get that right back up. Hopefully you're still hearing me okay. I think I might be overweighting my computer with applications open today. Chat me over if you guys don't have my audio. Otherwise, I may just kind of continue on without the PowerPoint. Huh, I'm having trouble relaunching. Give me 30 seconds and hopefully I'll be right back up. Oh, bummer. Son of a gun.
Adam, go ahead, just tell them that joke you know.
Yeah, right. Fill some dead space. I might just skip over the PowerPoint section for now and kind of jump right into the meat of it. Conrad, can you confirm that you still see my screen here in my browser window?
That is confirmed.
Perfect. So let's just kind of go into our visualization screen. Okay, and I've got 4 days here in the month of August, and we're going to start by looking at the old time of use rates. This again was the November of 2017, or also the grandfathered rates of today. But what I really want you to key in on is the bottom of the screen. And you can see that that on-peak window had previously been defined from 11 a.m. to 6 p.m. And you can just really visually see how the solar production curve, this happens to be a fixed tilt solar production curve, lines up pretty nicely with how that 11A to 6P window previously was defined. Okay, well, things have radically changed. And the new time of use rates that are now in effect in SDG&E territory, and I was also going to kind of mention this before I got cut there on my last slide deck, as a lot of folks are aware, are about to go into effect in both the SoCal Edison and PG&E territory, or much later in the evening. And in the SDG&E territory, you can see here it starts from 4 p.m. and extends out to 9 p.m. And right straight away, you can see how much less production is getting kind of captured under that curve. So frankly, the bottom line here is that a lot less solar production is now getting valued at that on-peak rate. And this is really the significant effect that is changing the economics of solar projects on the commercial side of the equation. So this is kind of my setup. What I'd like to do now is step into our case study where we're going to be modeling a fixed tilt roof-mounted system versus a PV booster single axis tracker roof-mounted system. So let me start on the fixed tilt side. And unfortunately, my computer's still bugging out a little bit, so I'm just going to assume that you guys are seeing things okay. So let's build up a fixed tilt system together. I've got a lead all configured. We're going to step right into step 4, and I'm going to add a system. I definitely want to plug, again, Evan and HelioScope. We are very close friends and allies with the Folsom Labs folks that make HelioScope. We have several hundred power users that use our 2 applications in conjunction with each other every day, building their designs and layouts and engineering in HelioScope, and then one-click importing that into Energy Toolbase to finish off with the financial analysis. For the comparison I do today, I'm going to be using the NREL engine just so we can kind of do an apples-to-apples comparison. So I'm going to use the PV Watts engine. And again, we're going to start with the fixed tilt. We're going to choose the recommended weather station, which again, for that same address in Vista that Evan was just looking at, is going to be the Carlsbad Palomar weather station. And I've already got my kind of pre-configured set of assumptions. We're going to do a 503 kW DC rated system, running it at a 10-degree tilt, 195 azimuth. And I've actually even got a price pre-configured. We're going to run this one initially at $2.50 a DC watt. So I'm not going to change any of the default assumptions on the PV Watt side. Let me save this. And let's just kind of do a quick interpretation of our results. We can see down here our yield on the fixed tilt system is coming in a little over 1,500 kilowatts hours by kilowatt, about 765,000 kilowatt hours of generation. If we were to really quickly look at a visualization of this fixed tilt system we just modeled, why don't I jump into a summer month and kind of maybe just scroll over about 5 or so days in the summer. And I'm just going to filter down to the, again, DGR energy costs. And there's that same effect we just saw a second ago, which is not a lot of solar is falling under that on-peak period that's now defined from 4P to 9P. You can kind of really visually see that. We've got another really cool view right here. If you were to toggle to the monthly electricity cost tab, I actually like doing this a lot, and I'll just kind of filter down to the solar generation side, right? So I'm kind of keying in on this here. And what we're doing here is we're taking that 8760 solar production profile we just generated from PV Watts, and we're overlaying it against that DGR rate schedule that features that new 4P to 9P on peak. And the part I'm really keying in on is right there. It looks like about 98,000 of our, what was it, 765,000 is in the on-peak period. I'm going to show you a summary slide in a minute, but it's about 13%. Not a lot. Not a lot is getting captured here as a result of, again, of that later on-peak window. Okay, so that's going to be our kind of our base case. Actually, there is one last thing I want to look at, and we're definitely going to unpack this in a minute, and that is the blended savings. You can look at this one of two ways. You can look at what sort of savings or avoided cost we achieved either in dollar per kilowatt hour terms, like we're showing here. So about 12.8 cents is the average blended value of each kilowatt hour. Or of course, you can kind of just look into dollar terms exactly how much it saved. So we'll show both of those in my summary slide in a minute. Okay, so that is the fixed tilt system. Let's step back out and now run a PV booster system, and then we'll kind of have our comparison all set up. Okay, so let's go right back into step 4. Every single other assumption of this project is identical. Really, the only things we want to change here is obviously running the single axis tracker instead of the fixed tilt. So we're going to use the same simulation engine, the NREL PV Watts V5 API, same weather station. So really the only real change I'm going to be making is over here. And per the PV Booster design guide, we're going to run this in a single axis backtracking mode. So we'll use the same system size, 503 kW DC. Per the PV Booster design guide, we're going to run this at a 30-degree tilt, 180 azimuth, and maybe Conrad can kind of talk on that when he comes back on in a minute. And then I did want to put in a cost value because I'm going to want to look at a comparison of the end project economics, fixed tilt versus PV Booster. So I'm going to price this one at $2.85 a DC watt, which is a 35-cent premium compared to the, compared to the fixed tilt system. And I'll, again, maybe let Conrad talk about that, or we can kind of discuss that in the Q&A. Obviously, that's a user-defined input. Okay, so let's kind of interpret our high-level results here. On the yield side, we're all the way up to almost 2,000 kilowatt hours per kilowatt of yield, translating to over 1 million kilowatt hours of year 1 kilowatt hours of solar production. And on the savings side of the equation, let's just do a really quick reference down here in the dashboard and kind of reference what the value of solar is worth. And we're coming in at about 14.5 cents, okay, per kilowatt hour compared to 12.8 cents on the fixed tilt system. So if you think about it, we really got 2 significant changes here. The production went up 30% in this case to 1 million kilowatt hours compared to 760,000 on the fixed tilt system. Additionally, the value, the average blended value of each kilowatt hour also went up. So it's like we're producing more and all of those kilowatt hours on average are worth more. So let's kind of unpack what happened there behind the scenes. I'm going to step into a visualization mode. And let's kind of go to those, maybe about those same 5 or 6 days in the month of July that we were just looking at. And right straight away, you can kind of see the change in shape from the single axis backtracker system. I kind of like referring to this, it just has a wider shoulder, right? This is certainly kind of starts earlier and ends later compared to that fixed tilt system. And you can see as I'm hovering my mouse right here, kind of in the 4 o'clock, 4:30, 5 o'clock hour, we're capturing more production in the on-peak window. So if I was to kind of look at the annualized result of this, we'll do the same thing we just did a second ago, and just look at all of those kilowatt hours of solar production distributed into the time window table. You can see now we're all the way up to about 150,000 kilowatt hours in that on-peak window, compared to under 100,000 on the fixed tilt. So not only are we producing more, we're producing quite a bit more into that on-peak window as a result of those wider shoulders. So I hope this is going to work. I really want to launch my PowerPoint. Bear with me 1 second because I had a nice summary view. Boy, I might have to hang on 1 second. I'm just going to pause my screen share. I think I'll be able to get this up in 30 seconds, but I really want to show this. Let me just pause my section of the screen share. I never have technical difficulties, and I'm having them today.
And Adam, while you're doing that, this is Conrad Chase with PV Booster. There's a number of user-defined inputs that we pass to both Evan and Adam. I didn't clearly mention all of these inputs are laid out in our PV Booster design guide that include spacing, row spacing, wiring suggestions and best practices, certain equipment configuration best practices, and also some step-by-steps for, selecting certain features in PV Watts and NREL. Like I said, all of that's included in the design guide created by us. Right after in the Q&A section, Rusty Wood from West Hills Construction, who actually designed, configured, and installed the system on the warehouse in Oxnard, can maybe speak briefly about some of those things. But those are all available in a follow-up email we will send to you as well as on our website.
Conrad, why don't you, I really want to circle back to my PowerPoint deck. I'm going to need just a minute to bounce my machine. Why don't you take it, and then I'll kind of maybe even have Rusty jump in, and then I'll circle back and show my summary slides, which will kind of really wrap up my section. But if you could improvise here and take the reins for a couple minutes, and then I'll be back on very shortly.
Well, yeah, I'll do one better. Sounds good? Perfect. So in prep, we also took the same results and summarized them as well. I got to be honest, the results that Adam's analysis showed were surprising to us as well, that there are just more kilowatt hours being produced in the time that matters when the price is higher using tracking. So that a 30% boost in kilowatt hours compared to a fixed tilt system using trackers is not linear. In this case, in these CNI deals, it actually translates to almost a 50% boost in additional savings for the client. A lot of this is going to depend on usage times, the roof condition. There's one of the complications about the CNI business in general is that every site is very, very unique. However, in concept, additional production in the hours and price where it matters most has an exponential effect when getting more power from your system. So would love to circle back with Adam when you're ready, but let's take the next few minutes through the rest of the available time, and I'd like to open it up for questions. We have your questions here that you have been submitting throughout the presentation. And the first one is actually to Rusty Wood from West Hills Construction. So Rusty, could you comment a little bit on your experience installing trackers and how was the project like in Oxnard?
Sure. Can everyone hear me? Hello?
Yes. I'm good.
Okay. Yeah, hello, everyone. Rusty Wood, West Hills Construction, Vice President. I run the energy division there. To go over what we experienced with this on this project, I'm going to hit mechanical, electrical, and just general administration economics because we found benefits in all areas after the project was done and taking a look back and definitely exceeded our expectations that we had set going into the project. So the first one that we found was and from our design, the mechanical penetrations to the roof over fixed tilt. So we did 8 foot on center, and what that was able to do was follow standard framing plans of buildings. And because each panel is independent of another panel, and the penetration is only set per panel, when we encountered certain framing members that were bowed, a lot of times these buildings are old and the framing plan changes a little bit as it warps from heat and cold exposure and just time overall. we were able to make minute adjustments to ensure we were hitting all structural members that we were supposed to. We find that is typically harder in a fixed tilt system, especially when you're relying upon certain on-center attachments to the racking to make sure you're hitting all structural members versus hitting the deck itself without a member attachment. We found that to be very beneficial to ensuring we would have no structural issues in the future. And we also found that depending on which way the members ran that you're trying to hit on the purlins, whether it's north, south, or east, west, which changes that design a bit, the PV booster was able to easily handle any framing plan that we stepped into on a roof. On top of that, it engineers to about 1 pound per square foot of additional dead load. And that helps out a lot with newer buildings. As time has gone on from the 70s, 80s, 90s, and 2000s, the computing power of engineers, they're engineering these buildings to an nth degree to minimize costs for building owners. So as you get into later buildings, we're really able to not exclude buildings based upon a structural dead load issue because you're only dealing with 1 pound per square foot of the tracker and its BOS components on the roof. And there's a lot less penetrations. Typically, you're 1 per panel versus 1.5 or 1.75 on a lot of the fixed tilt systems. And we prefer mechanical attachments over ballast. So you can do ballast with this, but that really helped out with this system for us to make us feel comfortable that it's waterproofed and you'll have no structural issues moving forward, and really open up the commercial market for us. Right. The next thing is electrical architecture. The electrical architecture, we ran 1 optimizer per panel. That dramatically decreased the electrical cost of the project, and we were able to parallel it perfectly with the communications and power requirements of the trackers themselves perfectly. So, and when we did our layouts, they were typically, I think they were 36 panel strings. So we did rows of 18, which fit, perfect conduit runs as it went east to west, 1 row south, and then over east to west. That helped out tremendously on the home runs because we were able to utilize the optimizers for that home run and really minimize that cost overall. And by doing that, you don't have as many home runs going back and a complicated electrical process. So you can use cheaper labor to set those optimizers and connect them, which dramatically increased the project labor. The last thing, what we found overall, we found a lot more stuff, and I'm trying to keep this brief, and we can, you can ask more questions after this. But because of the extra savings from an administration and economic overview, we were able as a contractor to make more gross revenue on the project, which I know that's why we're in business, right, as contractors and developers. But because of that extra savings that we were garnering on the project as it related to the extra benefit of the time of day rates for this particular site's utility tariff applied to the meter, we were able to still peel off some of those extra savings, give that back to the system owner, which really created the gap between fixed tilt and the PV booster dual axis design. And still make more gross revenue to the company, which I really enjoyed as my fiduciary as a vice president of the company to bring in. So that was really nice, being able to double end the benefits for the company and the tenant. I'm sorry, not the tenant, but the system owner, because of that. And there's just less labor overall on the install. You're dealing with less racking, less penetrations, less waterproofing. If you do ballast, you're moving less ballast, less weight onto the roof. less conduit runs. So it really became a great product overall, and dramatically increased our expectations in savings and gross revenue on the project. And the system has been running flawlessly since we've installed. So we are very happy about that. And we had specs, not knowing what we were going to garner out of it. We had specced about 20% increased production, and it's running about 30%, a little over 30% on the project, which is making our client very happy.
Great. Thank you, Rusty. That was fantastic. While we still have you in this mode, we have 2 questions from the field, which are related to, in your experience having installed a lot of systems on roofs, what was the kind of, if any, additional cost for installation using PV Booster? You kind of hit on it a little bit, but just the actual hard labor to get it in. And then as far as operations and maintenance of the system, been installed about a year. Any comments there?
Well, we found that it wasn't an increase to install over fixed tilt. We found the labor to install it was less than a fixed tilt system. The equipment's a little bit more expensive, which you can deal with the economics, because the savings of electrical generation and those economics makes the levelized cost of energy that much better over fixed tilt. So, but to answer directly, the install cost, labor, materials, waterproofing, BOS of conduit, wire, and that associated DC labor was dramatically less. I mean, I believe it was about 30 to over fixed tilt.
Great. And to follow up on that, related to install, we have a full installation guide, step-by-step, and we're happy to answer any of the nuances to that if you guys have questions offline. And we also have a very detailed O&M manual with failure rates, estimations, and costs, etc., also available on our website. We're wrapping up a little short on time. Do you want to pass this back to Adam Gerza?
Yeah, I would like to. Conrad, let me jump back in here. Perfect. So again, apologies on the technical difficulties. I just had a crash, but I definitely want to do a quick summary of the comparison analysis we just ran. So at least I was able to get through that. Let's just kind of quickly move through these slides. On the left, you can clearly see the fixed tilt versus the PV Booster model we just ran. Again, both using the PV Watts engine. On the yield, let's start there. Okay, so again, just in percentage terms, we achieved 31% more production on an annual basis, PV Booster one-axis tracking versus the fixed tilt system. The kind of big number, and I think you probably already mentioned this when I dropped, Conrad, is the increased savings. So this is really where you're getting that double effect. Not only do we have 31% more kilowatt hours, those kilowatt hours are worth more on average. That's that 14.5 cents compared to the 12.8 cents for this particular run. So that's a really kind of significant double boost on this particular project. And let me actually just unpack that a little bit more. So why that happens is, again, because of that later 4P to 9P on peak period. So as you can see here, the on-peak kilowatt hours, on-peak PV kilowatt hours on the PV Booster, about 153,000 compared to 98,000. So that translates to a 56% increase in on-peak production. Again, 31% increase in total PV production, but so much more is happening in that on-peak window, which is really driving that math. There's one last thing I want to kind of throw in here. Hopefully this screen displays. You guys seen my visualization screen, I attempted to kind of just overlay the two on top of each other here. So this again is like the fixed tilt system, the normal bell curve we're used to looking at, and I'm going to now overlay the PV booster profile on top. Now this is a little bit different because here I am in a winter month. Okay, so this is January 10 through January 13. And I think the takeaway here is not only are the shoulders wider, right, and we're capturing more in the on-peak period, but the highs are higher. And this is a result of the fact that we modeled the fixed tilt system at a 10 tilt 195 azimuth versus a 30 tilt on the tracker system. So that's also kind of driving this effect if you were to expand that out wider or kind of toggle over to a summer month. Again, basically, we're producing more at the right time, and that's really driving that effect. A lot of folks want to ultimately bake down their analysis to financial metrics, right? So everything we're looking at right now is just pretty much avoided cost. A lot of times you'll want to say, okay, well, what did that do to a payback period? Or maybe an internal rate of return on a comparison basis. So we used all the same assumptions across the steps 1 through 3, and just running this into a simple cash purchase. And I think on the incentive side, just so I have a kind of disclaimer on what I modeled with, pretty standard stuff. We're taking the federal tax credit, we're taking federal bonus depreciation, and we're going to also claim a state maker's depreciation in both examples. And let's just really quickly, lastly, look at that slide. So again, the total install cost, I'll leave that to Conrad and the Rusty Woods of the world who really understand project pricing and install pricing. I'm just using 35 cents in this particular example. And you can see down on the bottom of the screen what that translates to in a comparison of both payback and IRR. It obviously really juices the savings of the project. Those increased, the 48% in avoided cost increased savings is certainly more than making up for the 35 cent per DC watt increase in total installed cost. So just to kind of wrap my section up, this is obviously one case study that we just looked at. I'm always cautious to say, drawing too general of conclusions off of one case study project. I will say that I did not really cherry pick this deal, right? If I was to run maybe 10 other load profiles with this exact same comparison analysis, I'm sure we would see some projects that get weaker results. That, again, the key number there was that 48% number, right? And there's some that would even be stronger. So this is just one project. I will say that the SDG&E DGR rate really does exacerbate and kind of, because the price signal is so sharp, right? The on peak, we could just really quickly peek at that maybe as a last order of business. In the summer, that DGR on peak to off peak energy rate is really, really sharp, right? 57 cent on peak, 23 cent mid peak. So that's really what's driving this 48% increase. And again, I think a big takeaway for other folks in other territories like SoCal Edison and PG&E, where similar changes are about to go into effect, you're going to need to run this analysis on that specific rate with that specific load profile. And that's really what, as you hopefully know, what Energy Toolbase specializes in. So I think I'll end it there and just pass it back for Q&A. Thanks, Conrad.
Thank you. So I'd like to unofficially wrap the call. I'd like to give a very big thank you to Evan and Adam for participating. So those of you that have to jump, I understand. You will get a follow-up email from us with the recording from the webinar and the Q&A, as well as a couple links to both Helia Scope and Energy Toolbase offer free trials with their software. So if you are not currently customers, you should take advantage of that through the follow-up email. And lastly, we are going to be at SPI. We are going to have a demo tracker unit set up at the Jinko Solar booth right in the front of the trade show floor. We've been working on a couple things with them, matching some of their high wattage modules with tracking to really go after the CNI space. And this will all be also included in the email, but there's a special breakfast we're having and hosting together with them. So with that, I won't officially wrap it. We do have a few additional questions from folks that I would like to answer together with Rusty at West Hills Construction, which the first, let's see here, about the comparison. So like I mentioned earlier, the nuances of the commercial and industrial space, every site is different, every roof is different, every load profile is different, and every objective of the corporate customer is going to be different. For sake of this analysis, we're illustrating one, how to lay out trackers on a roof, and two, really comparing a same size project benefit and the impact that has on delivering the lowest cost of kilowatt hour. What our hope is that through the design guide and some of these design presets, you guys can use these tools to run as many scenarios as you like, and definitely not trying to push a square peg into a round hole, but for the sites that tracking and this type of thing makes sense, absolutely should be evaluated and looked into. So with that, let's take a couple more questions. Those are, 1 second. Right. All right, so let's start with Rusty. Are you there?
I am.
Great. So we have one more question about just O&M cost. So obviously operation and moving parts is a concern and a potential risk in projects. You know, been there, done that in our own projects in the installation side of the business. So over the last year, you know, what has been your experience with additional costs on the system that you've installed and expectation going forward?
We really haven't had an increase of cost as it relates to standard. I've just because of the technology and it being new, we've increased our O&M on-site visits just to do visual checks of things, but we haven't found anything for replacement. So right now we've got 100% uptime on the equipment at about a year under production. So if we're talking standard O&M, it's running perfectly right now. If we didn't consciously increase the visits, so far it is not anything more than fixed tilt. And in fact, right now, right now it's the washing is less that we're finding because you have less panels. So there is a benefit there as you're relating to either kilowatt hours of system size between fixed tilt or just kilowatt DC of system size. Unless you're matching the panels, that is one that we're finding that's less, but we haven't had to go out any further as it relates to more inverter O&M, more motor or breakdown of the system. Things can also be done remotely. So if we have to do a reset software-wise, it's very easy to do that without rolling to the site, but we haven't needed to do that at West Hills Construction personally. So I would say overall the O&M is less so far over the last year by at least 30%, directly related to panel washing. Got it.
Yeah, and just to follow up one bit on O&M, and you, like I said, you can see all this in our design guide. What's unique about trackers, at least ours, is that each one is kicking off data. We know the positioning of it. We know if there's an error, if there's a fault, etc. there have actually been 0 motor faults in the last year on this large project. However, if there were, the O&M service provider will know it. And, you know, if 1 unit breaks, 5 units break, etc., over an array, there is a threshold where that would even warrant a truck roll. So because a tracker would stop tracking, because one tracker is driving one panel, the string itself is not out of commission, as that architecture is totally separate. So it would really require a critical failure of a area of panels or of some other sort of event to hit out a bunch of wiring or something for it to even warrant a $500 truck roll. And like I said, all that's detailed in our O&M guide. Rusty, we got one more question related to this comparison. Obviously, when making a comparison, you know, this is much of a looking to solve for kilowatt hours based on tracking. But in the real world, there's the option of cramming way more fixed tilt or even flush mount PV into a defined area, even though it may be more inefficient. Is it somehow going to yield a better financial output or return for the client and the EPC? Would you be able to comment on that?
Absolutely, yeah. So we did this comparison. We did it at a lot of different azimuths for our project. And while at the face, it looks like it's not apple to apple, but you can do it apple to apple, because at a certain point, the trackers are facing west. And if you have or westerly as it goes through the day, so you can grab that from a certain time frame or parabolic curve and match it at that. But because the system is plateaus, and what we find in the when we take a look at the production of monthly, and we have commercial grade monitoring on the site, so we can go down to 15-minute intervals, and we do model. We are seeing greater plateaus than what you would see on average production, whether it's from Helia Scope or Energy Toolbase or PV Syst. And that's helping things out from an economic standpoint. But if you think about it, if you want it to apples, you either, what is your apples to apples? Either kilowatt hour or kilowatt system size. And you're going to need to increase your square footage use of fixed tilt to match whatever your base case is for the PV booster. So unless you have a ginormous building, what we find is you start getting hampered by all the other mechanical attachments, not attachments, but mechanical equipment on the roof, such as skylights or HVAC units. So sometimes we found roughly 60% of the time you couldn't even make an apple-to-apple comparison in the Southern California area between fixed tilt and PV booster, because you just couldn't get the additional fixed tilt up on the roof. With PV booster, because each panel is independent on 8 foot on center, you have that flexibility of where you want to place each panel perfectly. So you'll have to do your own evaluations, but you're going to have to think about it in a little bit different because you can cover those same time frames. And it gets even better when you start looking at it, you know, playing the rate arbitrage with batteries as well. But because you're plateauing so much, that's really where a lot of the economic gain. But you can do it yourself. You'll find the same things that we came up with. If anyone wants to talk even more with more specificity on that comparison, I'm more than happy to get into it. But I think you'll be able to find that it matches pretty close to an apple-apple. It's just the numbers and how you're looking at it. But the more data you put in, the more you're going to find that the PV booster destroys fixed tilt options.
Yep, thank you. Yeah, and Rusty's available as a preferred partner of ours to help answer questions, walk you through anything you have as a concern, or maybe even help you with your project if you need help getting an actual bid. And
I'd like to comment on Ellie Rothschild. When you go down to a 5 degree tilt, The 30% evaluation is against a 10-degree tilt. So you're going to have to put even more above a 30% increase on your fixed tilt because you're going to be producing less. You know, your break even between 1 degree and 20 degree is when you start seeing some diminishing returns is at 10%. So while yes, you can cram more kilowatt DC on the roof, but what are you doing? You're minimizing your production. You're increasing your capital costs because you just have a lot more equipment as you relate per watt. You're closing that gap.
Hello? Oh, sounds like we lost Rusty.
Son of a gun. I just went on mute. Can I don't know where my computer just muted me, but I'd like to answer Ellie Rothschild as it relates to the.
You answered almost completely there.
Oh, you heard me. Okay.
Yeah.
So, you know, you're going to have some other things that you're not thinking about right now, but definitely run the evaluations because you'll find that as you do that and as you bring that down, yeah, you're going to have more space, but you're going to have a lot more CapEx. You're going to have to add 40 or 50% more fixed tilt to still match the same kilowatt hour output, which is still going to be off because we're talking annual aggregate, but when does it relate to when you're injecting it to the TOD of the tariff? And as you start playing with the azimuth set of the fixed tilt system to match that increased system size, you're just going to keep increasing the benefit gap between fixed tilt and PV booster. At least that's what we found in our opinion.
Yep. Great. Well, I'm going to wrap it up at this point. One last final bit to answer maybe like 4 product related questions. There's additional resources, you know, design guide, data sheets, etc. on our website. The PV booster tracker is a single axis and 2-axis design. The 2-axis design has been retooled and is coming out in Q1. It's flexible and can accommodate any module. It has, you know, can attach, can be part of a ballast design. Obviously, it has to adhere to local wind codes. It is literally a rack that moves. We did not invent tracking, but we invented how to put it commercially on a rooftop for the right price. For those of you that have additional questions and would like support with your project, just reach out to us at lopvbooster.com and or respond to the follow-up email from this presentation. So with that, I'd like to also thank you, Rusty, for participating, and thank all you guys for participating as guests and for your comments.